Hello everyone, my name is Atharva and today we are going to do an integration problem that's quite interesting. So let us have a look at it. If you already know integration, let us do it together. Right? Okay, we're going to see this integral x squared by a plus bx whole square dx. Right? So have a second to pause the problem and try it for yourself. Okay, so let's try solving this problem step by step. So as you can see, if the integral were only to be x squared by some from n, we have just written it as 1 by n integral of x squared, right? So what's the thing that's the problem here? So the problem here is the denominator, right? So the thing that's actually troubling me is the a plus bx whole square, right? So let us do something via the rule of substitution. Let us put a plus bx as a term t, just for the sake of it, right? So let us write this whole integral we've gotten in terms of t. Okay, so let us write it here that our t is equal to a plus bx, right? So let's derivate it because I want to write the whole term in terms of t, right? So I want to write dx in terms of dt. So differentiating both sides is gonna be quite a good option. So dt is equal to derivative of a constant is 0 plus derivative of x is b. So b by dx of x whole times dx, right? So what you have here is dt is equal to b dx, right? So what does this mean? Dx is actually equal to dt by b. So let us put this dx into our dx in the main integral, right? So what we get is yeah. So integral x squared by our a plus bx is actually t, right? So t whole square into dx. Dx is dt by b. So it's going to be dt by b. I can rewrite this integral as 1 by b, because b is a constant here, right? So 1 by b into x squared by t squared dt. Now what's the problem here? We have to write x in terms of t to actually integrate the whole term with respect to t. So let's go back to our first equation here. And by the looks of it, we can see t minus a by b is actually equal to x, right? So let us just put Rx of this into this new term we've gotten with respect to t. So 1 by b integral t minus a by b whole square. Right? So t minus a by b whole divided by t square dt. Right? So this term what we've gotten right here looks quite beautiful honestly, because all the terms are in with respect to t. We have a constant c and b, which makes this integral quite solvable. So let us solve this integral step by step. So to continue this integration, I'm going to write here a few rules, right? So integral of x to the power n is equal to x to the power n plus 1 by n plus 1. And there's another quite a simple integral, that is integral of 1 by x is equal to log of modulus x, right? So using these two formulas, try integrating the above expression that we've just obtained. I'm giving you a minute. Yeah. So anyway, let us just continue. So what we're gonna get here is let me just erase the whole word and just keep this beautiful term that we've gotten. So rewriting our term here that we just obtained, a minus a by b whole square by t square into 1 by b dt. Right? 1 by b integral, the denominator of this term is going to get multiplied by the denominator of the other term. So we're going to get a minus a whole square by d square t square dt. According to our knowledge, b is actually a constant, right? So let us put it outside the integral, giving us 1 by b cubed integral e minus a whole square by t square dt. This is quite easy to integrate. 1 by b cubed is aside, a square plus b square minus 2ab dt. Now, let us use the fundamental theorem that we all know about fractions. That is, if something is equal to a plus b by c, you can always write them as a by c plus b by c. And the same rule is applicable for integrals. So, let us suppose we have a term that is the integral of a plus b by c, right? So I can write this as integral of a by c plus integral of b by c. I hope you get the idea. So let us solve this term. First try it out for yourself and check it with my answer. Right? Okay, let's just continue our spree. So 1 by d cube integral 1 plus a square by c square minus 2a by t dt. Now let us separate our terms according to this expression we've just obtained. So we get 1 by b cube, right, times the whole thing. That's going to be integral of 1 is a square integral of 1 half t square. I'm doing this because a is a constant here, and hence it will come outside the integrand minus 2a integral of 1 over t. This whole is going to be with respect to t. Right? So 1 over p cube integral of any constant other than 0 is x, right? But if it's x, it's going to be with respect to the x. In our case, we've taken t, so it's going to be with respect to dt. You're going to get t plus a square. What's the integral of 1 by t square, you suppose? So you can add t 1 by t square as e to the power minus 2. If you were to integrate this using the rule I've shown before, it's going to be t minus 2 less 1 over minus, that is equal to minus 1 by t. Okay, so just continue this. So it's going to be e squared into minus 1 by t minus 2a, and integral of 1 by t is ln t, right? So modulus ln t. As you can see, we've actually come to our final result here. You must remember that we put t equal to a plus bx in the starting. Let me change the markup. So, so our final expression is 1 over pq times a plus bx plus a squared into minus 1 by a plus bx minus 2a modulus ln a plus b. That's our final answer. Hope you like this question.